So we've looked at functions here. We looked at the linear functions, f of x equals mx plus b, the lines. We've looked at functions, f of x equals ax squared plus bx plus c, the quadratic functions. Well, another name those go by are polynomial functions. Those are examples of polynomial functions. Polynomials are just, well, they're sort of like this, but they can have degrees higher than 2. You just keep adding x cubed, x to the fourth, so forth and so on. That's polynomial. Well, so yeah, those are polynomials. That's degree 1 power. That's degree 2. The largest power is 2. So what we're going to look at now, though, are polynomial functions with degree greater than 2. So we know a little bit about those, hopefully. Now let's look at polynomial functions degree greater than 2. All right, so here on the handout, what I start with on the front there is polynomial. These have polynomial degree 3. 1/4 x cubed minus 2, x cubed plus 2x squared minus 11x minus 12. The third one is f of x equals x cubed minus 2x squared minus 3x plus 5. Here's the graphs of those. Real quick. Because I want to make kind of a quick point, but it's a helpful one. So that's 3, 4, and 5. Oops. Negative 2x cubed plus 3. And x cubed, negative x cubed plus 4x squared plus 3x minus 8. We'll talk about how to maybe come up with these graphs in a little bit, but real quick point. Yeah, so as you can see, for an x cubed graph, these are all x cubed graphs, right? They're all x, somehow involve x to the third power. Well, unfortunately, this is a line, this is a parabola. It's kind of hard to generalize what an x cubed graph looks like because some of them look, like this. And some of them go up, down, like that. But what we can generalize about this is what is known as the end behavior. And let me just circle kind of the end behavior that we're talking about so we can focus in on that. What we can generalize is something about the end behavior. Yeah, they may go up, down, back up, or they may just got a little wiggle in the middle there. That may be what they do. But notice here, the end behavior is consistent. And one thing we can generalize about the end behavior here is we got this end is down, this end is up. Okay? This end down, this end up, this end down, this end up. Now, on 4 and 5, it kind of switches around, but it's still one end's up, one end's down, isn't it? And so, generally speaking, what we can say about third degree polynomial functions is the end behavior, one end is down, the other end is up. Whenever we have a cubic function, a third degree function, one end is up, one end is down. Now, it can vary because here we have the left end down, here we have the right end up. It switches on this one. Right end, left end is up, right end is down. And so there's a little distinction to be made there, but you're with me there. The end behavior, one end is down, one end is up. Down, up, or up, down. Now, obviously though, hopefully, I gave you enough examples here, that we can tell, again, by looking at a specific coefficient, how it works. How does this work? How do you think this is going to work? How are we going to tell if it's this end down, this end up, or vice versa? You're looking at the A again. We're looking at the A again. Just like here, we can tell if it opens up or down that parabola. If you look at the A, on each of these, of course these are ones. Over here we've got a is -2, here a is -1. Yeah, it all depends on that a again, doesn't it? All right, so that's what we call the leading coefficient test for.
Okay, so a negative is going to be right side up?
All right, so here it is, leading coefficient test. The A for third degree polynomial function. If A is greater than 0, A is positive, then the end behavior, we've got, so if A is greater than 0, like 1, 2, and I erased 3, but like 1, 2, and 3, we've got the left end down, right end up. So the left end, what did I say? Left end is down, right end is up. If A is greater than 0, so left end down, right end up. And then it just switches. If A is less than 0, is negative, then switch it around. Left end down, left end up, right end down. Okay? So, I mean, it's not a whole lot of information, but it does provide us some good information there. We know the ends have got to alternate, one end's up, one end's down. This just tells us which is which. Okay? So, A and B on the front side there. Well, we've used this, how we've used this. So we've got A f of x equals -3x cubed minus 7x plus 6. Really, it doesn't really matter what after the third degree term is. This stuff doesn't really matter whether it's negative, positive. It's what the first term is. And so here I've got A is -3. And so what is the end behavior?
Left end up, right end down.
The left end, it'd be this one, right? Left end is up, right end down. And the way we use that is when we go to the graph, because that's our ultimate goal here is to graph these, pretty accurate graph, try to. What we're going to do is just say, well, left end is up, right end is down. And then we'll fill in the other pieces in just a moment. But that's because, like we said, it could, swoop down and just have a little wiggle. It could go up, down, back down, or down, up, down. We'll figure that out. And then B, okay, so on B, you got to be careful because, yeah, the A is not -5, is it? It's -5 plus 2x squared plus 4x cubed. This is not the A here. Why not?
Because it's not ordered.
Yeah, the A is the leading coefficient. What's times the largest power x? Yeah, this is A right here. So it could try to trick you. Not really, but sometimes they move those functions around. Don't put them in descending powers. So you just have to watch it. The A is there, so the end behavior would be the top one, right? The left end, so if A is greater than 0, how is it? Left end
Down.
down, right end up. Okay. Is that okay? Any question? All right, so flip to the back side there, and I've got 4 examples of the 4th degree. So f of x equals x to the 4th. Most basic one. Number 2. And that's got a complicated graph, isn't it? And that's g of x is x to the 4th minus 3x cubed, blah, 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 okay? Number 3, let's do 3 and 4 here. So 3, we've got g of f of x minus 1/4 x to the 4th minus 2, so that's like this. And then number 4, g of x negative x to the 4th plus x cubed, blah, blah, blah. Got on the paper there. So again, there isn't a basic shape for an x to the 4th. It can go down and back up, it can go up and then back down, or it can go, okay, so you get the idea. But, just like with the cubed graphs, the x to the 4th graphs, well, what we can tell just from the equation is the end behavior, right? So, the leading coefficient test for 4th degree, very much the same as the 3rd degree, except what do you notice about the ends here?
It's positive, both ends are up.
Both ends are up or both ends are down, isn't it? They don't alternate, they're the same in either case. Either both ends are up or both ends are down. And of course, it all depends on the A, doesn't it?
Yep.
Yeah. If A is positive, they're both up. If A is negative, they're both down. That's 4th degree, okay? So that's called the leading coefficient test for 4th degree polynomials. If A is greater than 0, we got a positive A, 1x to the 4th, 1x to the 4th positives. So if A is greater than 0, it's easier because both ends are up. If A is less than 0, well, that goes the other way, both ends down. Now, there may be a lot of other stuff in the middle. There may be some ups and downs in the middle, or it may just be go up and then back down, but that's what we can definitely tell from the equation with the A. So on A, on the back side, I've got f of x equals x to the 4th minus 9x squared minus 25. And then B, g of x, 7x cubed minus 2x4 minus 5x squared. So again, just a couple examples. So in behavior on these,
A opened up.
yeah, we got an A here is 1, positive, isn't it? So that, all we can tell just from that is both ends are going to go which way?
Up.
Both ends up. Now over here again, they're tricky sometimes. What about the end behavior on this one? Same thing?
No.
Ends down.
It's down, yeah, because here's A. It doesn't matter. A is not necessarily the first term. A is the term times the x to the 4th, the largest degree term. That's the A, the leading coefficient. So we got a cubed 4th term, x to the 4th and x squared. So the leading coefficient, the A, is what's times the x to the 4th. So again, we've got A is less than 0, so that would be both ends down. Okay? Now, we can actually generalize this a little further because if you look at the bottom two graphs, you've got f of x equals negative x to the 5th plus 3x squared minus 2, and then f of x is x to the 6th plus 3x cubed minus 2. And so you know about, notice about the x to the 5th, we got that, and then the x to the 6th graph, something like that. About the ends here. Well, the x to the 5th, they alternate as well. On the x to the 6th, they're both up. And so the generalization we can make is this is more like the x cubed, and this is like the x to the 4th. And so what do you think is the key ingredient there?
The degree.
Degree odd?
Even.
Degree even, yeah. And if you think about it, it also works for the x squared because on x squared they're both up or both down, aren't they? So it also works there. So if it's an odd degree, they're alternating, up, down. If they're even degree, they're both up or both down. So the last thing there, all right. So we've got j of x, 4x to the fifth, minus 8x squared plus 9x. It's 11. So the end behavior, well, it's a fifth degree.
Left down.
A is positive, so it'd be left down,
Right up.
right up. This is an odd degree, so they alternate. The A is positive, so it's like the x cubed. The left would be down, the right would be up. And then k of x equals negative 9x to the 6 minus 10x squared plus 50. The end behavior on it,
Both ends down.
Down.
Both down.
both ends down, okay. Because
Even, and it's negative.
you got an even powered, x to the 6th, and you got a is negative, so that's both down, just like our x to the 4th graph right there. Okay.
So would it be more accurate to say that the test would be the leading coefficient test, instead of saying like the fourth degree polynomial even